Okay, I am going to amend the video I sent out. I'm going to add to it. I felt like I didn't do a good job of explaining method 1 with this example. For ionic compounds, it's a bit easier to see when there's a redox reaction because ionic compounds involve a full transfer of electrons to even form. So oxygen is more electronegative than iron. It just takes the electrons from iron to give these charges, and it's easier to see that there's a redox reaction occurring. And you just use the charges to figure out the oxidation state number. So in this case, it's pretty straightforward. I want to go over an example where we just have covalent compounds. It's not quite as straightforward to determine if there's a redox reaction. So for this reaction here, we have methane plus oxygen going to carbon dioxide and water. If we're using method 1, we're going to use electronegativity and the periodic table to help us figure out oxidation states. So to do that, I first need to figure out the oxidation number based on bookkeeping. So ON bookkeeping of valence electrons. So bookkeeping for valence electrons goes a little something like this. And this is also outlined in the lecture notes, so feel free to go review those as well. You look, are there any lone pairs? Whatever lone pairs are on the atom belong to that atom. In methane, there are no lone pairs, so we have to look at electronegativity to see who gets the valence electrons. Carbon is more electronegative than hydrogen. This is a winner-takes-all game, so all the valence electrons in these bonds, which is a total of 8, belong to the carbon. So carbon has 8 valence electrons. Meanwhile, hydrogen only has 0, has none. So we're going to say oxidation number carbon, hydrogen, oxygen. So we just said here it has 8 and this has 0. And oxygen here, not applicable because there's no electronegativity greater difference. Like oxygen and oxygen have the same electronegativity. From the periodic table, I know that carbon usually has 4 valence electrons when it's not bonded to anything, and hydrogen has 1. And I got that from the group number on the periodic table, which we've talked a lot about before this chapter. So now if I assign these oxidation states, to do that, I'm just subtracting the periodic table number of valence electrons minus the oxidation number, and that's going to give me oxidation state. So 4 minus 8 is -4, 1 minus 0 is +1. Now elements are 0 because there's no difference in electronegativity. So these are the oxidation states on the reactant side. Now let's look at the product side. We still have carbon, hydrogen, and oxygen. We're going to look at similar things, but just on the product side. So we're still going to do the oxidation number. We're going to look at the periodic table, subtract them, and get the oxidation state on the products. which is periodic table minus OS. So between carbon and oxygen, the oxygens are more electronegative. Now the oxygens also have lone pairs, those belong to the oxygen. So oxygen has 2, 4, 6, 8 electrons in this case. And same goes for this oxygen, 2, 4, 6, 8. Oops. So they are equivalent. We have 8 valence electrons. Carbon has 0 valence electrons. This is from the oxidation number bookkeeping. Let's check. Oxygen here should also have 8, 2, 4, 6, 8. Yep, in water. And then the hydrogens have 0. According to the periodic table, carbon usually has 4, hydrogen usually has 1, and oxygen usually has 6. If I take these differences, I get plus 4 for carbon, plus 1 for hydrogen, and 6 minus 8 is negative 2 oxidation state for oxygen. So now to answer if these is a redox reaction, I'm looking for 2 changes. I see that carbon went from an oxidation state of negative 4 to plus 4. That means carbon lost electrons. So carbon lost electrons. That equals it got oxidized. Leo. Hydrogen, nothing happened. It's plus 1, it's still plus 1. No change. Oxygen went from 0 to minus 2. Oxygen had to have gained electrons in that case, because electrons are negative charge. Gaining electrons is a reduction, or GER. That means this is a redox reaction. Okay, hope this helps. Look at the notes. I also spell out the steps for method 1.